This video is entitled Anti-Gravity, the Death of Newtonian Physics, Part 2. So what I'm showing now is 10 drops of magnets in each section. They're dropped 10 times and it's recording the fall rate that occurs. Obviously it's running so quick that it's very difficult to narrate. And what I'm putting up in this video is the speed at which it falls, over 4 meters. So it's all pretty quick and it's very difficult to narrate. So what I'm going to talk about is Newton's laws of motion. F equals ma, which is F being the force of gravity, m being the mass, which we've talked about, the mass of these objects that we're dropping. One set of magnets are attracting, the other set of magnets are repelling, and so their mass is the same, but they fall at different rates. So the acceleration is different, which is challenging to the laws of motion. So I'd like to talk a little bit about, obviously because it's very difficult, the speed at which everything is running at, to actually talk about anything that's going on. So what we have is a picture of 3 sets of Newtonian magnets. They're all the same. So that gives you the mass. They're bolted together. Some are attracting. The one set is attracting, the other is repelling. And each of these experiments are dropped 10 times. What we do in this experiment is start the point at the first frame where it's released from the hand, and where the click occurs, which is the impact, that is where the video is cropped. So on the first set, the attracting magnets were dropped 10 times. They fell 4 meters, that's 400 times 10, and they achieved that in 3 seconds. The second time we ran as a control to see if we can match it, and the attracting magnets fell 4 meters in 2.99 seconds. Now we understand that these things are, need high definition equipment and need other people to replicate these things anyway. You could use lasers, but any metals, laser switching, but any metals involved in the experiment can obviously skew the data. The second set of 10 were repelling magnets. They weren't actually tightened right down, just to see if there was a different effect. Over 4 meters they fell at 2.81 seconds. And the repelling magnets dropped 10 times. In the second set of 10 fell 4 meters in 2.83 seconds. So we're looking at under 10%, but we're looking at a differential. It could be that the equipment is not suitable for recording at these speeds. There was some diligence put towards this. Some of the frames that when the magnets bounced, we had to take them out. So what can explain this? If this is proved to be right, I know Lockheed Martin engineers have reproduced this, so I know that other people have been able to reproduce this. So what is actually going on? What does this mean for gravity? What does this mean for our linear mechanistic model and Big Bang? Well, it means a lot, in fact. Atheism through the back door, in effect. Material out of everything, rabbit out of the hat kind of physics. So anyway, so what we're showing is a magnetic field attached to the Newtonian magnets, and what I propose is that this is what is happening. The magnets with repelling fields have a weaker, well, we can call it a less interactive or weaker or split magnetic field, and therefore they travel through the magnetic fields quicker because we know these magnetic fields are present. we know that copper magnetic fields create an effect also, which shouldn't, because it's a non-conductor of magnetism. In fact, every single atom has charge, so therefore every single thing under those principles should be affected by magnetic fields, and gravity should not have a constant rate. Obviously, with the attracting magnets, they slow, and therefore they must be interacting with a magnetic field to slow it down. Those are my conclusions. So, what can we say about this new law, or you could call it Muir's law. Unfortunately, I think Tesla, Hutchinson, and Lockheed Martin got there first, so I wouldn't be as arrogant to suggest that. But these are the predictions that I'm making. Is that the first prediction is that the closer you get to stronger magnetic fields, the stronger gravity becomes. And I think that's somewhat proved, although they give a different explanation to it. These fields are more tightly packed at the poles, and therefore the magnetic effect, if there is a magnetic effect within the concept of what we hold as gravity, then you would expect it to alter the rate of gravity. And the equator and the poles have different gravitational speeds under testing. So that's the first prediction, which is obviously a known prediction. It can be observed. You could test it on different magnetic areas, to see whether that variation occurs. The second is, as the magnetic field fluctuates, so will the rate of gravity. So you get yourself in a magnetic low spot and high spot on the Earth and test these rates of fall, and you will find the differentials if you can develop the experiment that is sophisticated enough to monitor this speed. And the third prediction is that gravity cycles will pattern around solar minimums and maximums. Every 6 years, latest findings, the Earth spins faster, then slower, over a 6, which I believe are linked to the high and low level magnetic fields of the Earth. A lot of this is to do with the Orban wave, the Nantaro effect, magnetic cooling, and also the spin of the Earth and the particles that create that spin of the Earth are all driving my research. Thank you very much. Goodbye.